Section 2.4 is solving and graphing inequalities. The first thing we're going to do is we're going to take x is greater than or equal to 2 and put it in set builder notation. Set builder notation is a bracket, x, straight line bar, which means such that x is greater than or equal to 2, and then you close that. So that is read x such that x is greater than or equal to 2. Next we're going to move on to the graph. The graph of that is going to be all the values that are greater than or equal to 2. So we start at the 2 and we use a bracket to represent equal to, and we shade everything to the right of that, everything that will make that inequality statement true. So our graph looks like that. The next thing we're going to do is our interval notation, which is related to our graph. It's easier to do the interval notation after we graph it. So it's simply bracket 2, and then it goes on to forever on the right, so we use infinity, and infinity never has a bracket. Let's look at some of the notes for interval notation. When we have brackets when the greater than or equal to symbol is used or the less than or equal to symbol is used. We use parentheses anytime greater than, less than, infinity, or negative infinity is used. So we'll go back. That's why we used a bracket right here for this 2, because of our equal to part of the inequality, and once again that's why we used a bracket here and a parenthesis for that part of the notation. So let's look at the next problem. Number 2, we're going to graph x such that x is less than -1. So we go on our graph and we're going to find, first of all, -1, and we're going to put a parenthesis, and we want all the values that are less than -1. That means everything to the left will be shaded. And for our interval notation, you read these graph. Interval notation is read left to right. So starting at our far left, we have negative infinity because it's on the left, and it's going to go all the way through and stop at -1. And because this is a parenthesis, our interval notation is also a parenthesis. Number 3 is a compound inequality in which we have two values that we're going to have a relationship to x. So as I read these, I like to start from the center and read out from the x. X is greater than 0.5. So I go to 0.5 and I want all the values that are greater than 0.5. That would be everything in this direction. Next, I'm going to read x is less than or equal to 3. So I go to 3, and now 3 gets a bracket because of that equal sign. And I want to represent everything less than or equal to 3. So that is everything in this direction. Our overall graph of this compound inequality has to be where the two overlap. So I'm going to darken the solution in black. I darken my ending points, and everywhere these two overlap, that's our graph. So if you were to, that's kind of like our work in progress. If you were to see just the graph without my work shown in red and blue, it would look like this. That's at 0.5 and 3. And then interval notation is easy from that point because we just bring down 0.5 and 3 with a bracket. Number 4, we're going to solve this inequality. First of all, let's get all the x's on one side. We're going to start with 2x, and we're going to do the inverse of it and subtract 2x from both sides. Whatever you do to one side, do to the other. x plus 4 is greater than or equal to negative 6. We are still trying to get x by itself, so we want to subtract 4 from both sides. And we are left with the solution x is greater than or equal to negative 10. If I wanted to make a quick sketch of this graph, I have negative 10. Because of this, I have a bracket, and it says x is greater than negative 10, so that's going to be everything shaded to the right. Interval notation, read it left to right, so we have a bracket, negative 10, and it goes on forever in the right direction, so that's going to be positive infinity, which once again, remember infinity always has parentheses. Our final problem, we're going to distribute this out and solve it. We're going to graph it and also give interval notation. So first thing we're going to do is simplify by distributing our parentheses out. That's negative x plus 3, bring down plus 2, distribute here, 6x minus 15, bring down the plus x. Now we're still simplifying our left-hand side, negative x. 3 plus 2 is 5, so we're going to add like terms there. Now we're going to simplify our right-hand side. 6 plus 1 is 7x minus 15. Now I'm going to try to move all variables on one side. You just start with the smaller variable and do the opposite of it. Whatever you do to one side, do to the other. Once again, our goal is to get the variable by itself, so I'm going to move 15 over by doing the inverse of it. Add 15 to both sides. 20 is less than or equal to 8x. Divide both sides by 8. When we simplify this, you're going to have 28. Divide a 4 out of each of them, and 20 divided by 4 is 5. And 8 divided by 4 is 2. So we're left with this. And I prefer to always have my variable on the left, so I rewrite, and that's open mouth pointing to the x, open mouth pointing to the x. Make sure you, when you rewrite this, that you keep the value the same. So now we're going to graph that. 5 halves is approximately the same thing as 2.5, and usually on a number line it's easier for us to see it as decimals than it is to do it in fractions visually. So when I come over here and I have, let's do a 2 and a 3 to represent, it's saying x is greater than or equal to 2.5 or 5 halves. 5 halves is going to be approximately here. It's going to be a bracket. It's a bracket because of that equal to part of it, and it's greater than or equal to. So we're going everywhere, shade everything to the right of that. And now once again we represent our interval notation by bringing down that bracket. 5 halves or 2.5, same thing. And it goes on forever to the right, so it's going to be infinity. And once again we say parentheses for infinity.